Now, again, if you use which units you use for pressure depends on which value of R you use. If you're going to use liters and atmospheres, you can use this one. Physicists typically use the top two here, joules per mole Kelvin, or sometimes liters atmospheres per mole Kelvin. Chemists will often use calories, but all three are valid. Okay, so our temperature is 273 Kelvin. Our pressure is 1 atmosphere. Let's go to our ideal gas law. PV equals N R T. We want to know the volume of 1 mole. So N here is 1 mole. So I'm going to use our value of R from the top. Doing that, I need to use this value for our pressure. We're solving for the volume. N is 1 mole. R, since I'm using those units, is 8.315 joules per mole Kelvin. And our temperature, 273 Kelvin. Okay. Go ahead and put all of those in, solve for V. Okay, what you should have gotten then for the volume is V is 0.0224 meters cubed. Okay, that's actually a value you need to remember, although typically what you'll see is it in liters. So truthfully, it might have been easier, or would have been easier probably, to have used this value, since we're going to get it in liters. Since there are 1,000 liters in the 1 meter cubed, that means our volume here is 22.4 liters. And again, this is a value it would be useful to remember. Okay, for any ideal gas at standard temperature and pressure, 1 mole occupies a volume of 22.4 liters. All right, let's look at another example here. Again, this example is from Giancoli. It's example 13.2, I believe, and it's on a helium balloon. helium party balloon. Assumed to be a perfect sphere. Has a radius of 18 centimeters. Room temperature, and by room temperature we usually mean 20 degrees Celsius. Its internal pressure is 1.05 atmospheres. Find the number of moles of helium in the balloon. And the mass of the helium needed to inflate the balloon at these values. All right, so let's start with our givens here. We have R, which is 18 centimeters or 0.18 meters. Actually, here's what we do there. Okay, our pressure, 1.05 atmospheres. Okay, I'm going to go ahead and change this into newtons per meter squared or pascals, but you could easily work it leaving it in atmospheres. So to change it into newtons per meter squared, that's 1.013 times 10 to the fifth newtons per meter squared. That equals 1 atmosphere. And when we put that into the calculator, what we get is 1.064 times 10 to the fifth newtons per meter squared. I'm going to keep one more significant digit here, and then at the end I'll round it down to the 3 significant digits. Okay, our temperature is 20 degrees Celsius. If we put that into Kelvin, we add 273 to it, so 293 Kelvin. Remember, to use the ideal gas law or any of the other gas laws, you need the temperature to be in Kelvin. Okay, the other thing that we need here is the volume. So our volume we can get from the radius of the balloon. It's a sphere. The equation for a sphere is 4/3 pi r cubed So when we put that into the equation here, put that into the calculator, what we're going to get is 0.0244 meters cubed. We're going to use the ideal gas law, PV equals nRT. We're trying to find the number of moles in. Okay, so we've got P, V, T, and R. We've got everything we need. Okay, just to check on the units, we've got meters squared down here, cancels with the 3 of the meters here. So we've got a Newton meter, which is the same thing as a joule. Cancels out there. We have Kelvin canceling out. So the only unit we've got left is mole. So we multiply these numbers together, divide by the product there, and go ahead and put those into the calculator. Solve for n. Alright, so when you solve for n, what you get is 1.07 moles equals n. Okay, we said that we also wanted to find the mass here. Well, we're going to use the definition of what a mole is. It's the mass in grams divided by molecular mass. Which is grams per mole. Okay. Helium is a noble gas, and so you find it as a single atom. So it's just a single helium atom. The atomic mass for helium is 4.003 grams per mole. So we have 1.07 moles equals the mass over 4.003 grams per mole. And when you multiply that across, you get 4.28 grams. And that's the mass of helium you need.